Yo, we're back with Professor McStud talking about the application of measurement. The first example, so we're going to take all of everything that we've talked about, volume, surface area, all that, put it all into one, look at it as far as a word problem goes. All right, so example one is talking about Jackie. She is using spherical, if that's a word, beads to border a picture frame. So she's really artsy-tartsy, wants to make this little cute picture frame. And so each bead has a diameter of 1.5 and we want to find the volume of each bead. So I've already had these drawn for you. And so the diameter is 1.5. That means the radius is 0.75. So we might need both of those. We'll see. We go to our formula for the volume of a sphere. It's 4/3 times pi times radius to the third power. So I'm not going to use the diameter. No diameter. I'm using the radius. So I go plug this in. 4/3 times, I'm going to use 3.14 for pi times 0.75 raised to the third power. So multiplying all those together, and you're going to get 1.8 millimeters cubed. So it rounds to the nearest tenth, so you got to round that up. Ends up being like 1.17 or 1.77 something. So it rounds up to 1.8 millimeters cubed. That's how you just straight up. You just got to be able to put the radius into there, and you're good to go. All right. So second example, we have a can of paint. Is 15 centimeters high and a diameter of 13.6. And so what is the volume? So a lot of times they'll say what is the volume, what's the surface area, but if they don't, sometimes you're going to have to determine that. It's 15 centimeters high and the diameter is 13.6, and that makes the radius 6.8. That's taking 13.6, dividing it by 2. I might need both or might need one or the other, so I'm going to make sure. Talking about volume. Volume is the area of the base times the height. So you're saying, I don't see area of the base. You got to know it. So I'm going to come over here and draw my little circle. The radius is 6.5. Capital B is pi times radius squared. So 3.14 times 6.8 squared. And you're going to get 145.194. So then I'm going to come over here, plug this in for B here, and have 145.194 times 15. Plug that in. That's my height. This is my height right here. That's H. Here's B. That's when I plug those in. So I'll plug those in, or multiply those two, and I get 2,177.9, round to the nearest tenth, and we have centimeters cubed. That's for a can. I have to know. It doesn't say a can is a cylinder. You got to know a can is a cylinder. All right, next example. Example 3, we have a piece of candy in the shape of a cone. It tells you it's in the shape of a cone. The height of the candy is 2 centimeters. And the diameter is 1. So the whole diameter is 1. That makes the radius be 0.5. I might need one. I might need both. We're going to determine the volume. The volume for a cone is 1/3 times the area of the base times the height. The base of a cone is a circle. Come over here, draw my circle. Draw my radius. It's going to be 0.5. So capital B is going to be pi times radius squared. So I'm going to get 3.14 times 0.5 squared. And that ends up being 0.785 altogether. Now I can go in and plug in everything because 2 is my H. Now I go through, I have 1/3 times the area of the base right here, 0.785 times the height, which is 2. And all together gets me rounding up 0.5 centimeters cubed, 0.5. So not very much. You know, we think about a candy, that makes probably pretty much sense because we're talking about a little piece of candy and 0.5 centimeters cubed, probably so. All right, so suppose the length of the edge of the cube is 4 centimeters, example 4, and find the surface area of the cube. It says find the surface area of a cube. All right, so a cube, every single side length is 4. Every single side length is a 4. A cube is like a square. Everything is the same measurement. So the volume or the surface area. Sorry, excuse me. We're switching gears now. Surface area of a prism, which is what this is pH plus 2b. Now it doesn't specify total or lateral. I'm going to go ahead and assume total. If it doesn't say lateral, go ahead and go with the total. So I'm going to take this base over here. Here's my base. I'm going to come over here and draw it. And so I have a 4 by 4 by 4 by 4 square there. So my perimeter of that is going to be 16. The area of that is also 16. It's kind of sort of kind of crazy. Usually that doesn't happen. Then the height of all of this is 4. There's my height. So I know we kind of said, what number did we not use in the base? Well, we're going to have to use 4 here as well. So it's a different 4. Plugging all of this in, P is 16. H is 4 plus 2 times the area of the base, which we found to be 16. So plugging all of that in together, you get 96 centimeters squared. Just changing gears here, talking about squared. Remember, we're kind of talking about how many little square pieces of paper can I put on there, and total would be 96. Little squares to cover that. All right, so now we're on to example 5. Brooke is making a cylindrical bolster pillow. Yeah, she's going to make a little throw pillow for her couch over here. And so the pillow is 18 inches long and the radius is 5. So this time, only time in this whole example here that they did give us a radius. So they're really nice on that one. We have 5 inches and then the pillow is 18 inches. That's the height of it. Now, I know it said long, but that's still the height. So it's wanting to know, it says how much fabric is needed for the pillow. Now you have to think about what a pillow is. It doesn't say find the volume, find the surface area. You have to think about this one. This one, when we talk about fabric, we're talking about going around the outside surface area. So I'm going to come over here. Here's my surface area, and I'm going to cover the whole thing. I'm not going to leave off I'm not going to leave off the bases because then your stuffing comes out when you put your head on it. So we have 2 pi RH plus 2 pi r squared. So plugging all of that in with the R is 5 and the H is 18. Pretty straightforward here. So it looks complicated, but really I think it's easier than prisms. So we have 2 times 3.14 times R, which is 5, times H, which is 18, plus 2 times 3.14 again, times the radius, which is 5, squared. You can plug this in directly, just like you see it on your calculator. Plug it just straight in. If you want to, you can add up this stuff, or multiply this and add the 2. I like to just put it straight in. Make sure I put everything in there correctly. And you get 722.2 inches squared. Again, kind of changing gears, talking about surface area, still part of area. So it's in our label here is inches squared. So that's what I have for you for application of measurement. We're talking about volume, talking about surface area. Sometimes it says surface area and volume, sometimes it doesn't. So you got to know the difference between the two. Volume is inside, surface area is outside. Professor McStud out.